Connection of capacitors. Capacitors can be connected in two different ways: series connection and parallel connection of capacitors. When capacitors are connected in series, just like this, capacitor 1, capacitor 2, and capacitor 3 are connected in series within the source or the battery, the charge on capacitor 1, which is equal to the charge on capacitor 2, which is equal to the charge stored on capacitor 3. Charge stored on each capacitor is equal if the capacitors are connected in series. So when capacitors are connected in series, total charge is equal to charge 1, charge stored on capacitor 1, which is equal to charge stored on capacitor 2, which is equal to charge stored on capacitor 3 if capacitors are connected in series. Next, when capacitors are connected in series, the total voltage delivered to the circuit, let's say V is equals to V total, which is equal to V1 plus V2 plus V3. The total voltage delivered to the circuit is equals to the voltage on V1 on capacitor 1, V2 voltage on capacitor 2 plus V3 voltage on capacitor 3. Now, capacitance is equals to charge over V. From this, V is equals to charge over C. V1 is equals to charge 1 over capacitance 1. Here, V total is equals to charge total over capacitance total. Now, instead of V total, it is possible to substitute Q total over C total. This implies as Q total over C total, which is equal to, instead of V1, Q1 over C1 plus Q2 over C2 plus Q3 over V3. Q3 over V3. Since the charge is constant on each capacitor, it is possible to say simply, it is possible to use one symbol for each charge stored on each capacitor because charge is constant for each capacitor. Therefore, Q over C total is equal to, here Q is common, Q into 1 over C1 plus 1 over C2 plus 1 over C3. 1 over C3. Q is cancelled. Q is cancelled both sides. Therefore, the expression for series connection of capacitor is given as 1 over C total, which is equal to 1 over C1 plus 1 over C2 plus 1 over C3. If three capacitors are connected in series, 1 over total capacitance or 1 over equivalent capacitance is equals to 1 over capacitance 1 plus 1 over capacitance 2 plus 1 over capacitance 3. Generally, for series connection of capacitor, charge is constant, whereas for series connection of capacitors, the total voltage is equal to the sum of each voltage drop on each capacitor. Next, parallel connection of capacitors. Two parallel connection of capacitors. When capacitors are connected in parallel, just like this, let's say this is battery or source, capacitor 1, capacitor 2, capacitor 3, C1, C2, C3, and V. These three capacitors are in parallel within the source. Because of this, the capacitors are connected in parallel. So the voltage drop on capacitor 1 is, let's say, V1. here V2, here V3. Now, when capacitors are connected in parallel, voltage is constant. For series connection, charge is constant, whereas for parallel connection, voltage is constant. V total is equal to V1, which is equal to V2, which is equal to V3, if three capacitors are connected in parallel. Voltage is constant. Next, the total charge for series connection, total charge is equal to the sum of each charge stored on each capacitor. Therefore, total charge is equal to charge 1 plus charge 2 plus charge 3. But charge is equal to capacitance times potential difference. Charge total is substituted by charge total is equal to capacitance total times V total. Since the voltage is constant, let's say simply V. So, capacitance total times V can be substituted instead of charge total. Charge 1 is equal to C1 times V1, simply let's say V because V is constant, and charge 2 C2 times V, charge 3 C3 times V. Therefore, let's substitute this expression instead of charge. Therefore, charge total can be substituted by this C total times V, which is equal to, instead of Q1, C1 times V plus C2 times V plus C3 times V. Therefore, C total times V, here voltage is common, V into C1 plus C2 plus C3. V is cancelled, C total for parallel connections equals to C1 plus C2 plus C3. Therefore, for parallel connection of capacitor, the total capacitance is equal to the sum of each capacitance of the capacitor. Total capacitance for parallel connection, total capacitance is equal to the sum of each capacitance of the capacitor. Here, example is given here. Look, these two, capacitor 2 and the capacitor 3, are connected in parallel within the battery, whereas capacitor 1 is connected in series within the battery. Therefore, this circuit contains both of connection of the capacitor, series connection, and these two capacitors are parallel connection. Therefore, the question says calculate equivalent capacitance, means total capacitance. Capacitance 1 for capacitor 1 is 2 microfarad. Farad is the SI unit of capacitor. This is also 2 microfarad, this is 4 microfarad. To calculate the total capacitance of the capacitor, first let's calculate the parallel connection of the capacitor by using the mathematical expression for parallel connection. Therefore, to calculate the total capacitance for parallel connection, let's say C in parallel, C capacitors which are connected in parallel, which is equal to simply the sum C2 plus C3. Capacitor 2 and the capacitor 3 are connected in parallel. The sum of the two is equal to the total capacitance, which is equal to 2 microfarad plus 4 microfarad. This is simply 6 microfarad. 2 microfarad plus 6 microfarad, which is equal to, this is 6 microfarad. This is the total capacitance for parallel connection. Therefore, this diagram can be rewritten as this is the first one, and this is the combined for parallel connection. Now, this is the battery, 12 volt. This is 2 microfarad, and this is 6 microfarad. Now, these two capacitors, this is C1. C1, this one, that means this is the total one, CP. So CP, they say this is CP. CP and the C1 are in series. Therefore, 1 over total capacitance for the circuit, since these two are in series, we apply the mathematical expression for series connection. 1 over C1 plus 1 over C in parallel, which is equal to 1 over 2 plus 1 over 6. 1 over 6 is 6. 3 plus 1. Therefore, 1 over C total is equal to 4 over 6, which is equal to 3 over 2. 1 over C total is equal to 3 over 2. Take the reciprocal of this number. C total is equal to 2 over 3 microfarad. This is the total capacitance of the circuit. The total capacitance of the circuit. The next question is determine or calculate the potential difference across each capacitor. Voltage on C1, voltage on C2, and the voltage on C3 calculated under this question. To do this, let's first calculate the charge, the total charge. The total charge. Now, total charge is equals to total capacitance times total potential difference. Total capacitance is calculated here, 3 over 2. Total capacitance is equals to 3 over 2. It is calculated. Therefore, 3 over 2 times V total is 12 volt. Here, this is 12 volt, which is equal to this is by 2, 6, 18 microcoulomb. Coulomb is the SI unit of charge. Now, this is the total charge delivered to the circuit. Since C1, capacitor 1 is in series within the battery, or it is connected in series, the total charge delivered to the circuit is equal to the charge on capacitor 1, because charge is constant for capacitors which is connected in series. Therefore, by using this total charge, which is the charge stored on this capacitor, charge 1 means charge stored on capacitor 1 is equal to 80 microcoulomb, which is equal to charge total, And V1, voltage on capacitor 1, is equals to charge 1 over C1. V1 is equals to Q1 over C1. We have Q1, 18 microcoulomb, 18 over C1 is 2, which is equal to 9 volt. Look, the total voltage delivered to the circuit is 12 volt. Voltage drop on capacitor 1 is 9 volt. The rest voltage from 12 volt, 9 volt if it is drop on this capacitor, the rest voltage is 12 minus 9, which is 3 voltage is transmitted to parallel connection of capacitors. The rest is dropped on this, which is 9 volt. Therefore, on capacitor 2 and capacitor 3, 3 voltage, 12 minus 9 voltage is transmitted to these two capacitors. Therefore, voltage on capacitor 2, let's say V2, which is equal to voltage on capacitor 3, V3, which is equal to 12 volt minus 9 volt, which is equal to 3 volt, Question number 3. The charge on each capacitor. Charge on capacitor 1 is calculated, which is equal to 18 microcoulomb. Since it is connected in series, the charge on capacitor 1 is equal to the total charge. But the charge on capacitor 2 is given as C2 Q2 charge on capacitors, which is equal to C2 times V2. C2 is 2 microfarad times V2 is 3, which is equal to 6 microcoulomb. Q3 is equal to C3 times V3, which is equal to C3 is 4 times V3 is 3, which is equal to 12 microfarad.